This is a mixture problem. A trucking firm stocks its antifreeze in a 30% solution and a 50% solution. How much of each solution should it mix to obtain 5,000 liters of a 35% solution? Something that we use in this problem and many other problems is that when we know a total, if we let x represent one of the values, then the total minus x is how we'll represent the other value. For this particular problem, I'm going to let x represent the number of liters of 30% antifreeze. Then using that idea of the total minus x, that will represent the number of liters of 50% antifreeze. Now in the problem, we have the number of liters. Well, for 30% antifreeze, we're going to let x represent that value. So I'm going to put an x here. For the 50% solution, we have that is 5,000 minus x. That represents the number of liters of 50% antifreeze. So I'm going to put 5,000 minus x in here. That's how many liters I will have of 50% antifreeze. And in the end, what do I wish to end up with? Well, I wish to end up with a total mixture that is 5,000 liters. So this value right here is already determined. I want to end up with 5,000 liters at 35% antifreeze. In a mixture problem, you are mixing different types of solutions. Here we're mixing a 30% antifreeze solution with a 50% antifreeze solution. And the key idea is the amount of antifreeze that I get from here combined with, that'll mean plus, combined with the amount of antifreeze that I get from here will equal this total amount of antifreeze. So that's what I focus on. Well, how much antifreeze do I get from this 30% solution? To know that, I need to change the 30% into its decimal form, which is 30 hundredths. And if I multiply that times x, that is how much antifreeze is in x liters of 30% antifreeze solution. How much antifreeze am I going to get from the 50% antifreeze? Here, I'm going to change the 50% to its decimal equivalent, which is 50 hundredths. And I'm going to multiply it times the number of liters that I have, which is 5,000 minus x. I have this amount of antifreeze coming from the 30% solution. I have this amount of antifreeze coming from the 50% solution. And what am I going to end up with? Well, I'm going to end up with a solution that's 35% antifreeze. That, in decimal form, is 35 hundredths. And how much is that solution? Well, we had decided, or it was given to us originally in the problem, that it's going to be 5,000 liters. Now, in a mixture problem, I could have drawn pictures of this, and maybe the pictures would translate into an equation. If I do a little chart like this bottom line right here becomes my equation. The amount of antifreeze that I get from the 30% solution combined with, which means add, the amount of antifreeze that I get from the 50% solution will equal the amount of antifreeze that I end up with in the final mixture. So taking this bottom row of this chart, I can write my equation. So I have 30 hundredths x combined with, so that's the plus sign, 50 hundredths times the 5,000 minus x, and that equals 35 hundredths times 5,000. Here's my equation that will allow me to solve for the value of x. Going ahead and simplifying this, solving for x, I have 30 hundredths x. I am going to distribute here, and that will give me the 50 hundredths times 5,000 gives me 2,500. 50 hundredths times a negative x gives me negative 50 hundredths x. And on the other side, multiplying out over here, taking the 35 hundredths times the 5,000, that gives me 1,750. Combining the like terms on the left side here, I have 30 hundredths minus 50 hundredths gives me negative 20 hundredths plus 2,500 equals 1,750. I would like to remove the 2,500 from the left side. I am going to subtract 2,500 from both sides. That will take this out of here. I'm going to subtract 2,500 from both sides. Remember doing that. That'll become 0 here, leaving me the negative 20 hundredths on this side. 1,750 minus 2,500 gives me a negative 750. My last step in solving for x is to divide both sides of the equation by the coefficient of x. And that coefficient is negative 20 hundredths. That will divide out here. And I will have x equals a negative divided by a negative will give me a positive. Negative 750 divided by negative 20 hundredths. This is something you should do on your calculator, and you'll end up with 3,750. In this problem, we were looking for two values. What we have found now is the first value, and that value was what we let x represent. Remember in the beginning, x was how much we had at 30% antifreeze. That was the number of liters. So that satisfies this value right here. The other value that I need to know is how many liters at 50%. This right here is how we express that. So I have 5,000 minus the value that I found for x, which is 3,750. And if I carry out that subtraction, I get 1,250. So the solution to my problem here is that I found for x 3,750. Now this is liters. Liters of what? Liters of 30% antifreeze. And you can write that in here. The other value that I found was 1,250. And what's that also? Liters. And that is of 50% antifreeze. So this one was the 30% antifreeze. This one was the 50% antifreeze. There are the two values. And these two values, when I combine them, 3,750 added to 1,250 is the 5,000 liters of 35% antifreeze.